Good morning everybody and welcome again to our course on Introduction to Mechanical Micromachining. In the last class we have seen some of the aspect of material for construction of different beds of the micromachining center, and we have seen that polymer concrete is one of the solution or one of the best materials which can be used for fabrication of the bed of micromachining center. Then we can discuss about guideways which can be used to move the table in the xy direction and the axis of tool, that is z direction, that what are the different guides way we can use for making those type of components. So, let us continue this topic in the guides way. So, in the last class we have seen this slide where we have two different type of guides ways. These are called the linear guides way and these are called the box type guides way. So, we will go through both the types and how these things are useful and these things is not useful in terms of advantages and disadvantages of both the cases. And we have seen that these are used for loading of this, means it will take the load of the component or the workpiece which we are putting. So, these are the guides way and this is the table on which you are putting your workpiece. So, this whole thing will move to and fro. So, that is one particular axis, let us consider it is a y axis and the same thing is for the x axis also. So, you need two such type of guideways for making x and y motion, and if it is a z axis then you need one vertical such guideway, so that you can get x, y, z all the motion together. So, what are the types? So, we have seen that there are two types, one is the box ways, that is more conventionally used in almost all the machines, and another one is the linear guides. So, these are the box way guides that we have seen in almost all the machine, conventional as well as CNC machines also. So, where it is used on a large percent of machine and are most commonly found on the large material removal machining centers. Why it is so? Because it has a large load carrying capacity, because if you see the size of this particular table which is moving on the top of this slide, where it is very heavy, and on the top of that again you are putting a workpiece and then you start machining. So, there are static loading from this workpiece as well as slide, and when you do machining at the time forces occurs because of the machining also. So, it is mostly used for the large metal removal machining processes where the size of this component and the machining forces are very large. But why it is not good for this particular micro machining? Because it is not good where the frequent axis reversal are required and the low frequency motion is needed for extreme accuracy. Now, if you see the size of this, because everything depends on the inertia. Now, if you consider that you are moving one object of a 50 kg and it is moving in this direction and suddenly you want to stop it here at this location, but it will not stop it because it has inertia, that weight is very high. So, if you want to stop it here, you have to reduce the motion or you have to stop the motion here at this location, because whatever the power supply you are using, if it is stopped at this location, then it will actually move slowly and it will completely stopped at this location. If you stop this thing here, then again it will move little bit because of its inertia. So, that is the big problem with the heavy duty guides way or heavy duty slide way, whatever we are using here. So, if that is also problem, one there is the low friction motion, because when the weight is more, at that time you know the friction is also very high. So, in that case, so that is very problematic in that particular sense. And other thing that we do not remove more amount of material, and this is particularly for the high material removal rate. So, we cannot use this particular guides way or the box ways for micro machining operation. So, that is the problem, because when you want to move axis from here to here, suppose it is the starting point is here and then you are moving at this location and instantly you want to move in this direction, that is not happening, because it will move little bit at this location and then you have to start this motion and then it will move to, because of this high weight of the component. So, that is not the right choice for micro machining applications. Another one is the linear guide way. So, it is a good choice for micro milling machines. So, how this thing happens, that it allows linear motion using the roller element or the ball and roller. So, this is one schematic diagram of this linear guideway. So, what are the things are there? So, these are the bearing, or there are two types of things. One is either you can use ball or you can use the roller, whatever is feasible depending on the applications. And then what these things are doing, that it will actually come into contact with this particular part. So, basically what we are doing, that instead of a two flat contact, what we are doing, that we are putting roller in between these two, correct. So, what is going to happen here, that the friction will be very less, because now here the contact area was very large, but here contact area is either point type or it is in case of ball bearing, and if it is roller then it is a line contact. So, in that case it is very easy to move those things. Right. So, here the coefficient of friction is 1/5 of the traditional slide bearing. So, whatever I just now shown you here, so that is comparison with that. So, it is 50 times less than the whatever coefficient of friction you are getting in the traditional part. So, that is one of the advantage, and can take up loads in up down and the left right direction. So, what is important thing here, that suppose you are loading from here to here, or you are loading from top to bottom, everywhere it will compensate. That means, there is no problem in the loading direction. So, that is one of the advantage, because when there is a thrust loading and the bending force is because of the machining process, at that time your guides or the guideway should not give any type of deflection or the deformation during machining. So, that is very good advantage of this particular part, and offer low static and dynamic friction and are well suited for high degree of multi-axis and complex motion. So, why static friction? Because now if it is in the stationary mode, only the balls are in contact with this part. So, you will not get so much of friction here, and dynamic friction, when they are moving, at that time again there is no any change in the contact points. So, number of contact points which are in the static position, dynamic position, that will not change. So, that is the very good example or very good advantage of using this linear guideway. So, let us see this particular video where almost everything is clear. What are the different components, what way you can define the different type of specification of the machine, and specification of the linear guideway, and where these particular guideway are used in the different applications. So, let us go through that video, and I will explain through that video step by step. So, here what it is showing, right. So, this is the position. Now, you can see that if the rollers are there, then you can reduce the friction of the components, and these are the different applications where we can use, we are using these right now. Right. So, there are different type of instruments. So, these are the things where we need a sliding motion for the different type of operations. In machine tools also available for movement of one component to other component also we requires. So, linear motion is that when you are traveling or transferring something in a straight line, then that is called the linear motion. Right. So, that is the advantage of these things. So, here it is a sliding, so resistance is very high, because your contact area is very large here. But when you are adding a rolling element here, either ball or the roller, then less resistances are there, because the contact points are very less, that apparent contact area between the two surfaces are very less. So, there are many applications. Now, you can see that these are the applications where we need very low friction motion, so that you can perform a particular operation without any problem. So, what is the initially what was the thought, that it was used as a linear bearing. So, what is the linear bearing? So, linear bearing is that there are balls available, and this is the bush of that bearing, and this is the shaft. So, here what is happening, that balls are actually moving in a this way only, in this particular direction, not onto this particular circular tap. So, linear bearings are not actually useful for torque transmission, because it does not have any type of restriction on the circular component. It will move in the forward and backward motion also. That is the problem with the linear bearing, because you will not get any slot. So, these balls will be scattered away when it is moving in the torsional parts. So, cannot transmit torque and poor load bearing ability and the short service life if you are using linear bearing as a linear mode. Right. So, what was the solution? That instead of a shaft only, so you create one key wall in the on the shaft. So, what is going to happen, that now this particular key, at that time you put the bearings on that is ball on that part, and then at that time it will create a motion. So, now your balls are restricted to move on the straight line, that means in the linear direction only. So, when you are moving in terms of torque, at that time it will resist the torque, it is not the free to move, because now we have a constrained motion on this axial direction. So, can only be supported at the end. So, what is the problem here, that when you want to use this particular thing, your supporting points are either at this end or this end. So, that is the problem. So, what if you are putting a very heavy load here, because ultimately what we are doing, that we want to put some workpiece here. So, this is the table, it is coming on the top it is a workpiece. So, this is the table and this is the workpiece and workpiece fixture, right. So, what is going to happen? So, these are the this is the end to end point, and this is our location, and this is loaded at this location. So, what is going to happen? So, this is going to bend depending on the total load on the shaft. So, that is creating a very problem. So, at the end of the scenario, readily flex when the subject to a radial load. So, this is called the radial load. So, let us see how it is going to happen. Now, see, this is going to happen when it is subjected to the radial load. So, that is because of that loading from the top part. So, this is also not the good way. So, final solution is that instead of using a cylindrical shaft, you actually go with the linear guideway. So, this is the guideway on which you mount all that sub assembly, like balls or the rollers and different type of constraint motions. So, this is the advantage of that part. How this will work, that you constrain the motion of the balls in such a way that it will circulate continuously when there is a motion between the rail and this particular ball. So, contact points are here, 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 and all these points only, it will not create any problem at the later stage. And we have seen that if contact is ball point, so there is no any issue related to friction, very less frictions is there. So, these are the number of balls which can be used, and these are the application by which you can get the things done. So, these are the sockets from where you can get this thing. Another advantage, that you are using a box type of thing. So, stiffness is very, very high in this case, because whatever other cross section you are using, like a circular kind of things, at that time stiffness is less, but here it is a box type and it is a structured thing. That means, it is in some different type of ribs part kind of thing. So, your stiffness will be very, very high in terms of the straightness and the load carrying capacity. So, this is the vertical motion, and if you transfer in other direction, then you can get the different kinds of motion. So, this is used for the ball bearing. So, now if you are using a ball bearing, then this particular motion will be something like this, and other thing is the roller bearing. So, instead of balls, what we are doing, that we are using a roller. So, you will get a line contact and you may get a more load carrying capacity in this case. So, now what type of different type of contacts are required? Now, we know that when you are loading something from the top and there is a chance of movement in this direction also, because now if your workpiece is here and you are giving a force in this direction, your cutter is cutting this, then there are ways of getting motion in this direction also. So, what is the thing, that there are 4 different type of contacts, this contact 2, 3 and 4, and you are using a single ball on both the sides. So, that is why it is called the 4-point contacts at this location. 2 balls are there and both balls have 4 contacts joined, 1, 2, 3 and 4. 2 is on the rail side and 2 is on this particular bottom fixture type. So, this is called a Gothic arc 4-point contact. Now, there is another way. So, now instead of 2 balls we are using 4 balls, but now what we have done that we have actually converted that, we have separated that contact points. Now, earlier if you have seen that we had a single ball and it is a 4 contact at this location, this and this location, correct. So, now what we are doing here that we are separating out these 2 contacts in a one bearing and these 2 contacts in the another ball. And now, these are the 2 contact and circular arc 2-point contact bearings. So, these 2 bearings will help and it will make sure that when you are loading from the top, this whole thing will not move or displace very seriously in that particular direction. Correct. So, its centers are contacting inside this part, and now if you use a roller bearing, then again it is the same thing here, but now you have more contact zone points are here. So, it is a line contact now, and because of the line contact your load carrying capacity increases. Now, you can add a little bit high amount of load for machining or the doing a little bit aggressive machining at the micro machining center. Correct. So, now there are different configurations that how we can define those things. So, it is called face to face configuration, DF face to face. Now, what is that thing? That now, if the center of this both the balls, if it is going inside it, then it is called the face to face configuration. Now, you can see that contact points are here. So, these are the contact points of this bearing and these are the this bearing. So, it says the center point, if you are extend the line of the center, then it will they will match at the inside the part, not on the outer side. So, that is why it is called face to face configuration. So, here this is the animation of that how this will work. So, what is the advantage of this thing, that if there is a little bit of error in the bed installation, because it will be very fraction of micron, but that will also matters when you do machining at a 0.1 or 1 micron of depth of cut, at that time it will create a problem. But this particular alignment will not create problem if you are using this type of face to face configuration. So, balls have adjustment ability that the block can move back and forth smoothly, even though there is the problem little bit kind of thing. So, now this is called back to back configuration BD type. So, here now these particular balls have contact point, that means center line moving in this particular direction. So, that is called back to back configuration. So, its contact is outside of that part. So, what is this? This is the simultaneous of DF configuration under the torsion part. Torsion means that means you are moving in this particular direction. This is the same thing for the configuration undergoing the torsion, that is called BD type, and this is called DF type. Now, if you see this thing is moving little bit more in that particular sense, because now it is not able to resist that particular torsion motion comparative to this particular DB configuration. So, what are the components of this linear guides way? So, one thing is the steel body that is required, because on the top of that what we are doing, we are mounting our workpiece so that it can move in the x and y direction. So, that is the first component, steel body. This is the rail on which your rolling element will slide. This is the rolling element. And the circulation system, because circulation systems are required in between these two. These are the end caps are required, because you want to restrict the motion, you do not want to extend these particular things beyond a particular limit. So, this is for end cap. So, that is for keeping this particular ball within the limit zone. So, once you get this end block, at that time it will circulate from this to this only, it will not create any additional motion. So, these are the things. So, it will move in a particular confined motion only. Correct. So, this is the way this particular ball will move in that direction, and this is the rolling element retainer. So, retainers are required because this particular retainer will make sure that balls are not actually moving in a other direction. Sealing devices are required because this is called bottom sealing, because we know that in machining operation we may encounter the different type of cutting fluids. Other than cutting fluids, there are different chips are available. So, if you want to reduce the contact of those things, dirt, chip and cooling to the bearing element, then what you have to do? You have to seal this component. So, bottom sealing will make sure that there is no any type of dirt or any type of other impurities are entering into the bearing zone. And other than that bottom zone, we have one this particular end cap also in this particular part. So, this is called end sealing. So, end sealing also function is the same, but it will prevent all these impurities to enter from the end part, and this is from the bottom part. So, first thing is the basic static load rating. So, what is that basic static load carrying? That suppose when a liftman is lifting one particular load, then what is this is the initial position. So, now if you are adding more and more load on this, what is going to happen? Your hand will be going down and down. So, this is the next position when you are adding more and more weight. So, what is happening? So, this is the initial load where it was at this location, and then if you are adding load continuously, your next position will be this one. So, this is your next position. So, when L0 minus L divided by L0 is 1th of, it is a 1 of 10,000 of this point. So, that is the called load bearing static load bearing capacity. So, right now we are not moving it. So, this is in the static location only. So, this is how we can actually calibrate this thing, that you put a load from the top and then it will give a load versus displacement curve on this particular chart. So, if it is permanently deformed, that means it has very low static load carrying capacity. So, this is what it is, it should not deform permanently, and so that is whatever the load it is happening, that is the load carrying capacity. So, total permanent deformation is 1 of 10,000ths of the diameter of the rolling element. Why we consider this rolling element diameter? Because we know here that this is the ball which is playing important role here, that it has everything here. So, this is the ball, and now this thing if it will deform means there is some type of deformation, either it is not circular now or it has some worn component from any other location. So, now what is going to happen, that your ball will be something like this. So, it is not completely in the contact with this part. So, whatever is this part is there, so that will create a clearance. So, this clearance will create a problem in the adjustment in this particular direction. When you are moving in the when you are calculating the distance at this particular location, it will not create problem, but at this location it will create problem. So, how you can define this basic static load rating capacity? So, it is assuming a load with a constant direction and magnitude. The static load at the instant when the total permanent deformation of the rolling element and the track surface is at the point of contact experiencing the greatest stress reaches the 1/10th of 10,000th of the diameter of the rolling element. So, what does it mean? Right. So, this is the when you are putting a load of a constant direction and magnitude, that is more important, because that is why we are considering is a static load. So, there is only one direction, we are not moving in other direction. So, it is mostly considered load from the top normal direction. So, what is happening, that we have a ball here, this is the rail. So, we consider this thing is the rail. The total permanent deformation of the rolling element. So, this is the rolling element and the track surface. So, this is the track surface, because we have to consider both the things. If there is a wear of the track, then again it is a problem that there will be a little bit of clearance. If there is a wear of the rolling element, then again there is a wear of that part. Track surface at any point of contact experiencing the greatest stress reaches 1 of 10,000 of the diameter of the rolling element. So, whatever is the diameter, we have to consider that the greatest stress should not reach to that location. So, that is the basic static load rating. Right. So, second thing is the permissible static moment. So, now these are the different moments. Earlier it was the load only, now it is a movement. So, it is a rolling movement. So, this is your vertical direction. So, it is moving on left and right. Right. So, when you see from the top, then it is called yaw motion. There this thing we have seen in that geometric error in the machining, and this is called the pitch motion. So, that is looking from the left side or the right side. So, these are the motion that is mostly happen when you are doing machining of the side cutting or something slot cutting, something like that. So, if under this condition also the same thing, that if the deformation is 1 of 10,000 of the diameter of the rolling element. Right. So, same thing here, but here instead of that constant direction load, what is happening, we are considering the moment of the constant direction and the magnitude. So, now it is concentrated to the moment. Under this particular condition, if the total deformation of the rolling element or the track surface at any point of contact experiencing the greatest stress reaches the 1 of 10,000 of the diameter of the rolling element. So, same definition, but there is a difference in the content. So, here we are talking about moment, and earlier case we were talking about the static motion. Now, coming to the dynamic load carrying capacity. So, now consider that these are all the balls, and they are all carrying some little bit of weight, and then they are running around a circle. So, this is what is generally happening in our ball bearing also. So, now under this condition, the 90% completes the whole marathon. So, when they are rotating in direction, 10% are dropouts. So, these are the problems in the bearing, and weight on everyone carries at this point is the term as a load carrying capacity. So, how you can define this thing, that after a batch of ball type linear guideway with a identical specification have completed their service life. So, consider the service life is 50 kilometers. So, and the maximum load ensuring that the surface of the rail track, block track and rolling element on 90% of the linear guides have no fatigue damage, corrosion or anything. So, if you consider that your whole system is running, that means all that particular guideway have completed 50 kilometer of run, that is particular specification for this part only. And if you find that 90% of this all the components does not have any type of these damages, then that is called the dynamic load carrying capacity. So, there should not be any problem of the 90%. If there is a 10% problem, that can be considered as a this particular dynamic load carrying capacity. Now, basic dynamic load rating capacity, that will ensure the rated dynamic load is used to assess the service life of the linear guideway. Larger the load bearing capacity, then longer is the service life, because we know that if it is a 50 kilometer, if it is reaching more than 50 kilometer, then actually our life is increased, because now 10% of that particular deformation or the defect, it will occur after 70 kilometer also, 100 kilometer also. So, in that case, it higher is the dynamic load rating capacity, longer is the service life of the component. Rated service life, again let us define that part again. So, again we are rotating these all balls in that same direction, and there are hundreds of these runners or balls, and when what is going to happen, that one by one if they are going down and down, then 90% runners are still in the marathon. So, that is 90% balls are still working at that particular location. So, this is how we can define that part. So, this is the under operation part. So, when you are working with this particular part and if you find that 90% of the things are still working in that system, then that is called the service life of that component. So, maximum distance can be achieved after which the 90% of identical guideway from the same product batch operating under the same condition and with the same rated load do not suffer any surface erosion. So, what is our objective, that what is the distance it can cover within 90% of the guideway without any deformation. So, that is the way, that means higher is this particular thing, more is the service life of the component. So, this is how we can define different type of things, and let me finish this lecture here. We will continue this video further in the next class. Thank you very much.